Chapter 25. Welding. Welding heats materials so that they melt and fuse together, creating a strong joint. Welding is mainly used to join two metals by heating the joint area where they touch or overlap. There are three main types of welding. Gas welding uses a gas flame to create the required heat. Electric arc welding uses an electric arc to create the heat. Resistance welding passes a large electric current through the metals to create the required heat. Welding is normally used to join metals of the same type. It is difficult to weld metals of different types together because they can have different melting temperatures and they may not dissolve well in each other. Similar to soldering and brazing, oxides that occur on the surface of metals prevent a good weld joint being created. Surface oxides must be cleaned off before welding. However, oxides will rapidly reform when the metal is heated, so solutions are needed to prevent oxidization from occurring when welding. A flux coats the metal surface and prevents it oxidizing with the air. Another technique is to use a shielding gas, which prevents air getting to the metal surface. Oxyacetylene is the most common type of gas welding. It combines two gases, oxygen and acetylene, to create a very hot flame. Acetylene gas comes in a maroon cylinder. Oxygen comes in a cylinder with a black body or white shoulder. Each cylinder is fitted with a valve and a regulator to control the pressure. The two gases are combined in the torch. The acetylene gas pipe is red. The oxygen gas pipe is blue. If the metals are being butt joined, a small groove is created between the metals to contain the weld pool. A filler rod is usually used to provide additional metal into the joint. The filler rod is usually coated with flux for convenience. The flame is turned on and adjusted. The flame melts the metals at the joint area and melts the filler metal and flux, which feed into the weld pool. Welding moves along the joint area. The metal cools behind to form a solid fused joint. Flux creates a layer of slag on top of the joint area, which may need to be removed using a surface grinder. It is important to use the right type of flame in gas welding. A neutral flame consists of equal parts oxygen and acetylene. It is blue with a small rounded white core. It has no chemical effect on the metal. A carburizing flame contains more acetylene than oxygen and is cooler than the neutral flame. It has an additional greeny-blue inner flame called an acetylene feather. A carburizing flame helps prevent oxidization of the weld area. An oxidizing flame contains more oxygen than acetylene and is hotter than the neutral flame. It can't be used to weld steel because it would oxidize it. It is used to weld non-ferrous metals and also for brazing. MMA is a type of electric arc welding that uses a consumable flux-coated electrode. The electrode holder is first attached to the power supply. The electrode is a short rod or stick which is clamped in the electrode holder. The electrode has an outer coating of flux and an inner core of filler metal. The metals to be joined are placed or clamped together. An electrical circuit is made possible by connecting the metals to the other side of the power supply using the earth clamp. The power is turned on. The electrode is brought very close to the metal, but not touching, and an electric arc forms. This creates great heat, which melts the metals at the joint area. The electrode also melts into the weld pool, which provides additional metal into the joint and supplies the flux, which prevents the metals from oxidizing. When the weld is cooled, the action of the flux will have created a hard slag layer on top of the joint, which may need to be chipped off or cleaned off with a surface grinder. MIG welding uses a shielding gas instead of a flux to prevent the weld area oxidizing. This results in a cleaner and better finished joint. MIG welding uses a special gun that supplies both the consumable electrode wire and the shielding gas. The gun is attached to the power supply. The consumable electrode wire is supplied into the gun from a reel. The shielding gas is supplied into the gun from a gas cylinder fitted with a regulator. We can see the gun can now supply both the gas and the electrode wire. The metals to be joined are placed or clamped together. The electrical circuit is completed by connecting the metals to the other side of the power supply using the earth clamp. The power is turned on. The gun issues the shielding gas over the weld area. When the electrode is very close to the metals, an electric arc is created. The intense heat from the arc melts the metals to be joined. It also melts the electrode wire. As the electrode wire is used up, more wire is issued from the reel. This continuous feed makes MIG welding faster and more efficient than MMA welding, where the operator must keep attaching new stick electrodes as they are used up. Because MIG welding uses a shielding gas instead of a flux, we don't create any slag and we get a cleaner weld. TIG welding is like MIG welding, except it uses a non-consumable tungsten electrode instead of a continuously fed wire. This means any additional filler metal must be supplied using a separate filler rod. The TIG gun is attached to the power supply. The shielding gas is also connected to the TIG gun. The gun supplies the shielding gas and uses a fixed tungsten electrode which does not get consumed by the welding process to create the arc. The metals to be joined are placed or clamped together. The electrical circuit is completed by connecting the metals to the other side of the power supply using the earth clamp. To supply additional metal into the joint, a separate metal filler rod is used. The gun issues the shielding gas over the weld area. When the electrode is very close to the metal, an electric arc is created. The intense heat from the arc melts the metals to be joined. Additional filler metal can be added using the separate filler rod. The shielding gas prevents the metals from oxidizing. TIG welding provides the most control over the welding process and the temperatures used, and is suitable for welding aluminium and thin steel sections. Submerged arc welding is an automated process for carrying out continuous, long, straight, repeatable welds on pipes, beams and plates. A flux dispenser dispenses powdered flux along the joint ahead of a continuously fed filler wire electrode. The flux dispenser and filler electrode wire are moved along together along a guide rail. The electrode wire is attached to one side of the power supply, and the metal to be joined is connected to the other side of the power supply via the earth clamp. The powdered flux is dispensed along the joint. The wire feed forms an electric arc underneath the powdered flux, which melts the electrode wire and the metals at the joint. The electrode wire is continuously fed from the reel. As the weld joint cools, a slag layer forms on the surface. Unused powdered flux is hoovered up and can be used again. Submerged arc welding is suitable for long, straight welds. The dangerous arc light and fumes are reduced because of the submerged arc. Electroslag welding is an automated process for joining very large, thick plates. The plates are arranged vertically with a vertical gap between them. A container area for welding is made at the bottom of the gap by using a starting plate at the bottom and a water-cooled plate called a shoe on either side of the gap. A flux dispenser is used to dispense powdered flux, and a reel dispenses the filler electrode wire. The filler electrode wire is connected to one side of the power supply. The starting plate is connected to the other side of the power supply using the earth clamp. Flux is dispensed into the gap between the shoes. The electrode wire is lowered into the flux and creates an arc. Heat from the arc creates a pool of hot molten slag. The arc and the hot slag melt the filler wire electrode and the edges of the metal plates. The electrode, filler wire and flux are continuously fed in. As the water-cooled shoes are raised, the metal and the slag cool to create a solid joint between the metal plates. Resistance welding generates heat by passing a very large electric current through the material. This locally melts the material and creates a joint if there are two pieces of metal overlapping at that point. Here we demonstrate resistance spot welding. Current is supplied by two electrodes connected to a power supply. The electrodes press in on the joint, and a pulse of very high current is sent through the joint. Resistance spot welding is very fast and easily automated. It is widely used in car production, where robot arms are used to weld body panels and other components. Resistance seam welding carries out a line of spot welds in order to create a long joint. The electrodes are in the shape of rollers so that they can be rolled along the joint or seam between the two metal parts. The metals are overlapped or folded to create a joint area. As the metals are being advanced through the rollers, pulses of electric current are sent through the metals. This forms a sequence of spot welds along a line. The spot welds can be overlapping. Seam welding is used for joining and sealing metal containers and for manufacturing products like domestic radiators. Welding is extremely dangerous and many safety precautions must be taken. Always wear a welding mask to protect eyes against blinding glare and hot metal splashes. Wear welding gloves and protective clothing to protect skin. Ensure ventilation systems are in place to carry away fumes. Gas welding equipment contains a number of built-in safety features. Gas cylinders and hoses have different standard colours, and oxygen and acetylene connections have opposite screw threads, so they can't be connected the wrong way around. Gas hoses contain built-in flashback arresters to prevent any flames returning to the cylinder. In electric arc welding, ensure the earth clamp is attached securely and keep the work area free from moisture, which could lead to electric shocks. Summary: oxyacetylene welding uses a gas flame created from oxygen and acetylene gases and a flux-coated filler rod. A layer of slag forms on top of the joint. MMA, or manual metal arc welding, uses a flux-coated stick electrode to create an electric arc to melt the metals. Slag forms on the joint. MIG, or metal inert gas welding, uses a continuous feed of filler wire and a shielding gas to prevent oxidization. MIG produces a cleaner weld without slag because there is no flux. TIG, or tungsten inert gas welding, uses a non-consumable tungsten electrode, a gas shield, and a separate filler rod. TIG allows the most control and is suitable for thin steel sheets and aluminium. SAW, or submerged arc welding, is an automated process that dispenses powdered flux with a continuous wire electrode feed to weld long straight lines in pipes, beams, and plates. ESW, or electro-slag welding, uses automated feeds of powdered flux and a continuous wire electrode to create a reservoir of hot molten slag, creating a weld joint between two thick vertical plates. Resistance welding uses electric current to create enough heat to temporarily melt the metals together and form a joint. Spot welding uses a single current pulse between two pointed electrodes. Seam welding uses multiple current pulses between two roller electrodes to create a line or seam joint.